In this example, I want to solve a triangle where we are given two sides and a non-included angle, also known as angle side side or side side angle, SSA. So what we need to do is we need to figure out, well, how many, since this is the ambiguous case, it's side side angle, we need to figure out how many solutions we have. And so what we're going to do is we're going to start with our given information. So we have draw the triangle and find the missing parts if angle A is 27 degrees, side A is 5, and B is 7. Now I know this is side-side angle because I have two sides and the angle that I'm given is across from one of the sides that I'm given. So that's how I can know if it's side-side angle as opposed to having the angle between the two sides. So what I'm going to do is I'm going to sketch the given information. Again, I like to have my reference line here, my given angle here, which is the 27 degrees, so that's set. Here's my side B, which is 7, and my side A, 5, is across from the angle 27. And what I need to figure out is this 5 here, is this going to be too short and not even form a triangle? Is it going to be the same as H, or is it going to be longer than H and be able to hit this at two sides and have two solutions? And so what I need to know is, from before we learn that, well, we want to compare 5 to H here. And so we want to find H. Notice we have a right triangle here. And in order to solve this right triangle, we can simply use sine. Sine of 27 equals H over 7. Sine of 27 equals H over 7. To solve this, we would multiply both sides by 7. So multiply the right side by 7 and the left side by 7, and we would get H equals 7 times the sine of 27. If we go ahead and calculate that, we get 3.178. So the height is 3.178. And again, what we want to do is we want to compare this length. 5 is greater than 3.178, which means there's going to be two triangles formed. And so there's the two triangles that can be formed. You probably could have guessed that there was two triangles since I had two situations here. Here, the B is acute angle. So I'm calling this triangle ABC even though it wasn't mentioned earlier. This is an acute triangle, or 5 could kind of swing over to this side and we could have B is an obtuse triangle. So we're going to work through how to solve something like this. This is the situation that just straight law of sines will solve. So we have sine of A over side A equals sine of B over side B. To solve for that, we can multiply both sides by 7 because we want to get B by itself. Multiplying both sides by 7 will give us that next equation there. Well, we want to solve for B, so we have to do the arc sine or inverse sine of both sides. On the right side, they're inverses, so the sine cancels. And so we want to do inverse sine of 7 times the sine of 27 over 5. Which gives us 39.46. So this angle right here will be 39.46. We need to find angle C. Well, these add up to 180 degrees, so 180 minus the 27 minus the 39.46 gives us angle C to be 116.55. And then the last thing that we need to do is find this side here, which is side C. We can do law of sines again. So sine of 27 over 5 equals the sine of 116.55 over side C. Here we can multiply both sides by C. to get c in the numerator, and then finish solving by multiplying by the reciprocal of this. Another thing you could do is cross multiply and solve. I didn't go through all the algebra work there, but we get 9.85 for this missing side. And so we solved our first triangle, but we have a whole nother triangle to solve when b is obtuse. Well, what we need to notice here when we have two solutions is we would set this up the same way. Sine of 27 over 5 equals sine of b over 7. We get the same thing. And we get to this 39.46. Well, that can't be right because b has to be obtuse. What we need to notice here is that if b is obtuse, this new angle b is going to be supplementary to the angle b we found before. The reason that's true, if we go ahead and extend this side here, and I'm going to put a circle in here because these would be, so let's draw in here. This would be our original B. I mean, our original side A. This was 5. Well, that's our first triangle that's formed there, which we see over here. If we swing this over and we put 5 here, we want to know what this angle is right here. Well, we can go back to geometry and we know that these two segments are the same. And if those two segments are the same, these two angles have to be the same because they are, that's an isosceles triangle. So this angle here, which we found before, that was the 39.46, has to be the same as this angle, which means we can easily find this angle over here. We can find that because that is a straight angle, so we simply subtract from 180. So that explanation, all of that to say, we solve our triangle here, we find angle B. As soon as we find angle B in this triangle, we can know angle B in this triangle over here because they're going to be supplementary. So again, we didn't have to go through all this work again. We could simply do 180 minus the 39.46, and that's going to give us angle B over here. I'm going to get rid of some of these things that I added in here. So we found here angle B is 140.54. Now we can continue solving this one. We know the 27, we know the 140.54. We can easily find angle C. Do 180 minus the 27 minus the 140.54 gives angle C to be 12.46. And then we can do the law of sines again. Sine of 27 over 5 equals the sine of the 12.46 over side C. And then solving that for C, you can cross multiply and then solve, will give us 2.37. So we were able to find both solutions of that triangle. Some of the key things were we solve this original one just using law of sines. Straightforward. Don't forget to solve the second triangle, and we can know that this angle that you found first in this problem, angle B in this triangle will be supplementary to it, which means you can just subtract it from 180 and you'll get this angle here.